flow problems. And remember, maximum flow equals minimum cut. So flow problems, we normally want to know about the maximum flow. So we know these things are flowing because we got these directional arrows on there. So then we know some things are flowing. And where are they flowing? They're flowing from the source to the sink. If we follow the arrows like so, we can see we're flowing from source to sink. So everything comes out of the source and everything ends up in the sink. And what we want to figure out is like, what's our maximum flow? What's our max capacity of this system? And to do that, we need to do a thing called cuts. So a cut is something that cuts all flow from the source to the sink. So an example, if I do things like that, I'm going to call this cut 1. Now cut 1, you can see there's no way of me going past that either direction that would actually allow me to get from the source to the sink without crossing that red line, that cut. So we know that definitely is a cut. And all we have to do is actually add up the numbers here. So we cut the 5 and the 12, so our flow here is 17. If we do another cut, because there's more than one cut here, we can do a cut here. We're going to call this one cut 2. And you can see we've got 10 and 12. So that those two lines that we've cut are 22. All right. And let me try another one. This one's a cut like this. This is cut 3. But the problem with cut 3 is it's not actually a proper cut, because I could go along here and I haven't crossed the blue line. So this cut 3 is not a cut. So we can cross that one out. Not a cut. Because remember, a cut cuts all flow from the source to the sink in a single cut. So what is the maximum flow in this system? Our rule is maximum flow, right, equals minimum cut. So what's our minimum value here? Well, we've got a choice between 17 and 22. Well, it looks like our maximum flow is going to be 17 as our answer. And that's how you work these things out. And there's only a few tricks with these problems, and we'll go through a few questions and show you what some of those tricks are. It's not a cut. Remember we had that cut 3 that didn't cut it there. There's also backflow. There's always going to be a backflow, and there's a couple of tricks even to disguising the backflow or making you think something is a backflow when it's not a backflow. And then there's the multiple sink and or source. Those are a bit rarer. Even if you spot them in a textbook, they're rare to see in exams. Not impossible, but rare. That tell us what we need to be doing. And that says we want maximum flow. So that looks like, and you've got a source and a sink. So we know that is definitely a flow problem. And so we need to start doing some cuts. I like to just do a straightforward. My first cut is around the source. So if I add that up, I've got 4 plus 6 plus 10. That gives me a flow of 20. I could do another cut. This is definitely the topic for different colored pens. This cut here, 2 and 8 and 10, that also gives me 20. But there's a number of other cuts I could do. I could do a cut like this, and I get 2 and 6 and 10. That gives me 18. And I've got to find different colors. And then I can do another cut over here, which is 4 and 10 and 8. Well, that gives me 22. So if you look at this, I can't think of any other cuts. It's quite a simple system. They don't normally give you very, very complicated ones if they're going to make you work out the cuts, because you could be there all night and it's always possible they make a mistake. So I would say my answer is definitely C, 18. Okay, another maximum flow problem, and they're talking about cuts and everything. It's quite obvious what we need to be doing here. Now, the first one is write down the capacity of cut B. Let's have a look at cut B. So this is your cut B, and we can see we've got a 3, a 2, and a 4. It's not that hard to add those up, and you get 9. Does it say what our units are? Just the number of deliveries. 9 will be fine. A very simple, easy question again. What's the capacity of cut C? But if you know anything about flow problems, this should set your alarm off for backflow. Backflow has got to be in there. All right. So what is backflow? So remember, we're talking about going from the source to the sink. And so you only count pipes that are flowing that direction through your cut. Now, just remember that through the cut you're talking about. Sometimes a pipe might be flowing forwards for one cut or backwards for another. This is the cut we're talking about, cut C. And we can see this line cuts and it's going that way. It's going from the source side to the sink side. Source side to sink side. Source side to sink side. But this one is going source side, sink side to source. So there's our backflow, and we feel happy because you knew it was coming. It had to be there. So we don't count the green one, we just count the red ones. So if we add up the red ones, we got 4 plus 6 plus 3, 13. And so we spotted our backflow. A lot of people probably put 14 because they didn't spot the backflow. Now, looking at this problem, don't forget your basic rules. We know there's no multiple sources of sinks here. There are issues with backflow we found with cut C, but this can be quite a hard one to work out. We already know that we got a 5, a 2, and a 3 for cut A, so we already knew that one was 10, and we knew cut B was 9, and we knew that cut C is 13, if I'm getting that correct. And we're now going to try and find a better cut. Now, this 6, we don't want to be cutting the 6. So that's obviously going to blow your total quite big. But we want to be try and get as many of the low numbers as possible. All right. Now, you could do a cut like this. It's 11. That's not much better, is it? Because again, we're cutting that 6. So how about we go around that? We can get the 2 and the 2 and the 4. That could get us 8. That's not looking too bad, but is there another line? We could do a line like this. That would also be 8. It's completely cutting off the source for the sink. But I think there's even a better one. And these are tricky to work out. 3, 2, and 2. I can get 7 for that. So there's the 7. That was quite a hard one. It says this question was not answered well. The answer of 9 from part A was often repeated. Look, seriously, it wasn't going to be 9. I think they should have given like some sort of mark for getting 8, because that 7 was not easy to spot. Okay, slight boo-boo last time I answered this, got the right answer, but with the wrong numbers. Let's try and do it right this time. So, we know this is a flow problem because it tells us we're trying to find the maximum flow. We also know that there's 3 edges that are labeled X, 1, 2, 3. And these X values differ depending on which cut you're looking at. And there are 5 cuts, A, B, C, D, E. And just looking at this diagram, I think we can say all the cuts are cuts. They're cutting right across the graph, so there's no problems with sources and sinks. And there's no multiple sources or sinks. They're quite rare, those kind of things. But what we have to look out is for backflow. And backflow is where we go sink to source. So we're watching out for that. So let's get started. Going to do a lot of coloring and cleaning up today. So let's start with cut A. And for cut A, X equals 1. So we're going to put a 1 here. Source to sink, source to sink, source to sink, source to sink. Add all those up. 11 plus 1 is 12 plus 10 is 22 plus 4 is 26. So far that's our winner because it's the only one we've checked. Let's try cut B. Now in this case, X equals 2. So we put 2 on the X because that's the X we're crossing. Source to sink, source to sink. Sink to source. That's backflow, ignore it. Source to sink, source to sink, source to sink. So we can add all these up correctly. 7 plus 2 is 9, plus 2 is 11, plus 10, and plus 4, you'll actually get yourself 25. This is a maximum flow problem. All right, so let's try the next cut. Now for the next cut, it's cut C. We go like so. Cut C says x equals 2. Now this is a different x. It's been cut with 2. And so source to sink, 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 source to sink. We're just going to add all them all up. There's no backflow there. 7 plus 2 is 9, plus 2 is 11, plus 8, 19, plus 3, 22, plus 4, 26. So it looks like cut B is still a winner. Just clean all that up. Let's go to purple now for cut D. And cut D, x equals 3. We are cutting an x, a different x this time, and we put a 3. We've got source to sink, source to sink, source to sink, source to sink, sink to source, source to sink. So adding up all those numbers, 5 plus 3 is 8, plus 5 is 13, plus 9, 22, plus 10, 32. All right, so still so far, the answer is B. And then cut E, well, although it says x equals 3, we're not actually cutting any x's. Source to sink, source to sink, source to sink, source to sink. Just add them all up. 5 plus 3 is 8, plus 9, 17, plus 10 is 27. It looks like if we think about maximum flow is minimum cut, it is the 25, which we said is cut B, where x equals 2. So we've got everything. And we did find the backflow along the way, so we know it's the correct answer.